for this session. Currently, I am the co-founder and the advisor to a new startup, fintech startup called XPay Life, and primarily I have been awarded with top 100 CIOs of the country. So multiple CIO awards have been like IT Next 100, Eminent CIOs of India, and CIO 200. So these are some of the latest CIO awards that have been awarded. Thank you. So let's continue with that. So I'll focus on the technology aspect as well. And because there are few management students, so I'll talk about in general how the startups get benefited from the data driven insights. Okay, right. So the agenda is like about I'll be talking about the data science and analytics, understanding the data mining. So I'll talk about the concepts of data mining and why now and what is next in data science. And then we'll take up some case studies for the startups. So I'll start my session with this a graph which is from the Gartner. This is called technology hype cycle. So latest one recently has been released, and a few points which I wanted to highlight in this are uh, this graph is primarily to show that what technologies are people talking about. So these are some of the technologies that are hyped and would be in discussion for next year or so, right? So like adaptive ML. So in the latest technology, you would see a lot of machine learning, data science kind of technologies in the hype cycle. So the at the top you would see a white one which is called social distancing technology, right? Our Arogya Setu app, that is also a social distancing technology from India. Similarly, we have lots of others. So it will become your digital sign for your medical health. So accordingly, now a lot of emphasis is being given to the social distancing technology. So that will become your health sign, right? Signature. So these are other technologies which I wanted to share. So let this health passport. So these are all mobile apps that we are talking. So it indicates the relative level of infection or risk a person is and whether they can gain access to building, supermarket. So now you would have this health passport with you, similar to Arogya's app, Setu app. And one of my previous colleague and a good friend of mine had developed this Arogya Setu. And recently in Digital India Awards, he was awarded or recognized with this development of a Arogya Setu app. And this is the health passport we are talking about. Next would be embedded AI. So, it has the potential to increase the accuracy, insights, and intelligence gained from the current and next generation sensors. So, even in those IoT devices, sensors, you would now have these embedded AI. Even the Intel chip, which is coming up recently, it has been announced. So, they would be releasing an AI enabled chip. So, most of the processing can and AI can be done at the chip level. So see the kind of focus that industry has. Next comes the responsible AI. So like you would have seen a lot of fake news coming up. So there is a need to identify those fake newses, and responsible AI has the purpose to assist the business in making a more ethical, balanced business decisions by attempting to reduce the biases. So it is like identifying the fake news. So that is the need of the hour because we have seen a lot of fake news coming up in the industry and people have been forwarding them. So uh, because of the generative AI. So generative AI is also a kind of a technology most often used by creating a deep fake videos and digital content. So because these fake news are being generated, so you need a responsible AI. Both go together, similar to virus and antivirus, right? Next is a AI augmented development. Most of the organizations have e-commerce sites. They have already started this concept of augmented uh, AI augmented development. So purpose is to improve the cycle time of the application. So this is specifically talking about that even in development, we would see a lot of AI approach in creating a high quality software. So Gartner also says that by 2022, at least 40% of our new development application development projects will have artificial intelligence as a co-developer in the team. That means there would be some 40% of these application developments would have AI as part of the development. So uh, I'm sure developers have, uh, most of you are from the technology stream, so you would understand that uh, it's hard, it's tough to develop those codes. So AI will surely help you out in as one of the developers in that team. By 2022, 10% of the new vehicles will have the autonomous driving capabilities. As of now, last year it was 1% or so. So a lot of emphasis being given in autonomous self-driving vehicles, and you would see 10% of the new vehicles will be kind of autonomous driving capabilities. Anyway, a lot of vehicles already have this canvas, so a lot of automation has already been done. A lot of sensors are there which guide you through the. Only the autonomous part is missing, which subsequently, when it gets tested and everything is all okay, 10% of it would be from the autonomous driving vehicles. So again, blockchain will create 3.1 trillion in business value. That's again one of the leading technology that people are talking about. The only challenge with blockchain, I would say, is that it's a bit complex, and you have to specifically write code for each use cases, which means that there are still less people to understand blockchain, and the use cases are still very less. Even though most of the banks have started using blockchain for eKYC process, right? So they keep all your documents within this blockchain concept. Similarly, the storage, computing, advanced AI, and analytic technologies will expand the capabilities of these edge devices. So in this IoT concept, these IoTs start sending the data to the central servers. So there is also a concept of edge devices, which means that a cluster of IoT devices from one particular region can communicate to a edge device, which can single-handedly communicate to the server. So not all millions and millions of IoT devices should connect to the central servers. These edge devices should communicate, and IoT should connect to the edge devices. And it says that these edge devices will start having the AI embedded as part of it. 100 million consumers will shop in augmented reality. That is again one of the, so we have already seen tractions now, and a lot of companies have started using the augmented reality. So it takes your image, or in augmented reality it takes your image, and then what dress you are trying to purchase, it will fit into you and how you look in that dress, right? Or a specs or whatever. So multiple, it can superimpose and try to give you a augmented reality image. 50% of the people collaborating in industry 4.0, that is also one of the leading domain which everybody is talking about. So next wave would be industry 4.0, which already started after COVID, because uh, less people are working on these machines, CNCs and robots, and they're all connected to the central servers now, which means that virtual assistant and intelligent agents would be interacting more frequently with these devices and would communicate according to the business plans. So these are some of the latest disruptive technologies that industry is talking about. So be it drones, a lot of we have started the tractions that deliveries have started with the drones, or in agriculture sector, pesticides have been using the drones, they have started using. Blockchain, another technology which is picking up slow, but subsequently in few years we would see a lot of traction in the blockchain technology. Big data, so like Viniji was talking about that railway reservation system, there is no database at the back end. It is all running on that. Earlier we were using a flat file which was using a key value. So key was your PNR and value was your the passenger details. So that key and value with a hash map was the recent big data concept. So no SQL we were also using some 30 years back or 25 years back when we were developing the Indian railway reservation system. Augmented reality and virtual reality, 3D printing. So these are some of the technologies that is disrupting the. So let's quickly focus on the IoT part. So because I remember I was working on a project in 2006 or 7, with Pollution Control Board of Punjab, and they had given us a project to use the sensors to identify which particular area in that particular river was polluted. So we had a sensor based device which we would dip into the river 1 kilometer apart, and every week we would collect those devices, connect to our laptops, transfer that data, and then we would do an analysis of. But now, after the communication part of the IoT has come up well, so because now these IoT devices are also able to communicate to the central servers through Wi-Fi or GPRS, so that has made the difference. So now we see millions and millions of devices communicating to directly to the central servers. So this is things which is this IoT and sensor based device. Connectivity, which is the data which is connecting over Wi-Fi or over GPRS, and the data which is transferred. It could be a big data, it could be in an unstructured format. And then when you have all that data, you need some analytical tools to identify the trends of that data. So we said 25 billion devices would be connected by end of this year. Massive volume of data. And a lot of security aspects have been taken care now, because some few years back, because of a virus attack on these IoT devices, which was called Mirai botnet attack, so which created millions of IoT devices sending requests to a particular server, and because of that, the requests were not served, and millions of the traffic was so high that the internet almost choked for 3 4 days. So we would have seen internet going down some few years back. That was because of these IoTs sending a lot of data, and because of the firmware or the malware sitting on that IoT devices, there was a hack, there was a attack on the servers. So this is a complete. If we talk about the building a connected and smart ecosystem for the startups, it is primarily these IoT devices. Then you have to use the big data, and finally the analytics part, which is presenting or extracting a lot of insights from the data. So I'll be talking about these in detail. And the full picture of, if we talk about, it is on the left side, we would see all the IoT sensors and data. So it could be your cameras, it could be smart card based devices, or a medical equipment, or a consumer goods devices, your uh, refrigerators, or your connected homes, right? Vehicles, buildings. So they all have IoT sensor based data, or it communicates through various communication protocols, be it NFC, Bluetooth, Zigbee, WLAN, or Dash 7. So these are different communication channels through which uh, it connects through 2G, 3G, right? Or even internet, and then through a gateway, which could be an edge device or a consolidating server, which is collecting all the data from different IoT devices. So your house may have one gateway, and all your devices would be communicating through that gateway to the internet. And finally, you have this data center, and through communication devices, finally, you get the data into a big data concept, where you can then churn your data, and you can then further use it for CRM services, billing, industry solutions. So you can generate a lot of uh, insights and analytics on top of the big data you get. So we have seen that large data has that this data has grown over last few years, I would say, right? So it is said that the data generated till last year has been generated this year itself. See the kind of exponential growth the big data has, and these are all unstructured data. So till recent years, we have been doing uh, only the SQL based databases, right? So be it select star from a table where conditions, so we fetch those data. It is very structured data, right? But now it is all be it streaming data, be it your likes, dislikes, so Twitter kind of a data, your images, your emojis that you use. So the data has become very unstructured. And the challenge is that the kind of a big data we get, so it is these tools, data analytical tools that are used to get the insight from these data now, and that is what we are going to learn today. So the new mantra, like whosoever has the data is the king now. So likes of Facebooks and Google, they have trillions and trillions of the data records that they fetch from each user, and they know the sentiment of each individual then, right? And what not they can do from your data. So the new mantra is gather whatever data you can whenever and wherever possible, which means that keep collecting data. And the expectation is that the gathered data will have some value either for the purpose collected or for the purpose not envisaged. So keep collecting data. That's the intent of the industry today. So big data analytics can be have been used in the smart healthcare, right? See, Corona vaccine has come within a year's time. It is all because of data analytics. I was reading an article which says that the whole of the world, all these scientists have started using data analytics to predict the behavior with respect to other viruses, with respect to other vaccines, and that was all simulations done on computer itself, and a lot of analytical tools were used to churn the prediction of different behavioral. So gene analysis and all that symptoms were all analyzed using data science. Similarly, smart cities have this homeland security, traffic control. They're all being done using IoT sensors and the big data collected. Next, we are talking about the Industry 4.0. So, manufacturing those interconnected devices and CNCs and robots, they will enhance the productivity. One critical part is like this log analysis. So, big data centers, what they have done is instead of a server failing and then you do a reactive analysis on that, so people have started analyzing the log, which means that the server or the hardware device, it starts giving certain symptoms and they get logged into the system logs. So there are tools now available to analyze those logs, so that the data or the symptoms can be analyzed and a corrective action can be taken before the server goes down, right? So data analytics have started being used in big data centers. Finance and banking, anyway, a lot of use cases are available. Retail, telecom, your churn prediction, whether you are going to change the service provider or not. So that is from your behavior, right? So telecom guys have started using the churn behavior. Trading analytics, search quality. So Google anyway regularly keeps changing the algorithm so that you get the best output from the search, and it increases the quality of the search. So it obviously gives us the opportunity to solve certain major issues like improving the healthcare and by reducing the cost and others, finding the alternate to the current conventional energy by using green energy, and predicting the impact of climate change, and also reducing hunger and poverty by increasing the agriculture. So these are all social aspects which data science would be using. So startups can pick up any of these burning areas which which will need data science. Some of the other areas which machine learning and data mining application areas would be astronomy, bioinformatics, drug discovery. We have already seen. In business, it can be through the effective use of CRMs. So you can do a structure, the clustering of the data, and then based on a selected product interest group, you can target those customers specifically and don't have to send all your mailers and your collaterals to everyone. You have to specifically target those customers which you get from the clustering analysis, or even a fraud detection. E-commerce sites, they all use like association rule. When you purchase something, you are likely to purchase something else, so they start giving you alerts that why not purchase this as well. So there is 10% discount if you add the other product. So similarly, they understand the psychology of those buyers, and accordingly they push their second products also. So that is what is cross selling. Manufacturing, sports, telecom, right? So these are different scenarios where data science is being used. Even government is using it for the surveillance systems, the crime detection. NCRB lot, so National Crime Record Bureau, they use lot of analytical tools to identify the crimes. Which area is likely to have more crime rate because of the trends or the patterns that is there, profiling the tax cheaters, and all that is from the government vertical. So actually, what is data science? So it is extraction of this implicit, previously unknown, and potentially useful information from the data. So like exploration and analysis by semi-automatic means of large quality of data in order to discover some meaningful patterns. And these are the logical steps to the data science. So you have some certain input of data, which could be multiple sources, like let's say Facebook, so social media, your Twitters, or from the internet, from your different database sources, right? Your presentation can have a lot of data, your Word documents have a lot of data. So data inputs can be different sources, CSV file, or your structured data, which is your database driven structured data. So then you have to filter all that data and do a lot of data pre-processing, so that the analytical tool understands the data in a particular format, right? So it is like feature selection, dimension reduction. So some of the variables may not be useful at all, or they would be of the same significance, same variable type, right? So you have to reduce it by using the dimension reduction methods. Normalize them, some data subsetting. So some of the data, like if I say I have two manufacturing units, one uses the same part A, as named as A, and the second unit, which has been taken over by some from some other company, uses the same part as part B. So now when you consolidate that data on your central servers, you would have data for A also, you would have data for B also. So somewhere you have to manage both of them together to say that A and B are a new part, which is, let's say, C. So you would like to see the summary of product C, which is A from uh, factory 1 and B product from factory 2. Accordingly, then this data subsetting, or you have to filter that data according to your data mining tools. Then you do so 80% of the time is in a typical data mining process. 80% is spent on this data pre-processing part. So when you have the data and you have made it filtered around to what the data mining tool would need, then 20% is used to model your algorithms and then test it on the test data. And then if some changes are required, you can send back to refining your data and then doing a data mining again. And when you finally get the information, that is what is the insight. And so that is what is called the data driven insight process. So some of the other definitions of data mining. So data mining is extraction of knowledge from large volume of data, that could be structured or unstructured. So again, it can also be called like knowledge discovery in databases, KDD, some people call it knowledge extraction, or data pattern analysis, data archaeology, data dredging, information harvesting, or even business intelligence, right? So these are various definitions of the data science. So let's focus on what data mining tasks are. So these can be classified in these major heads, which is a classification, like it is predicting an item class. So classification is then you are classifying the total data in, and you are predicting a item class accordingly. Clustering, so finding the clusters in the data, what similar kind of data you are clustering. So accordingly, the marketing teams, they use clustering methods to identify one set of users of the similar nature, right? And then you can then do a target marketing to those specific set of customers. Association rule, so when you are likely to purchase A and B, and then you are likely to purchase C as well. So that's the kind of association rules that so you would have seen that a lot of e-commerce market basket companies, what they do, they manage their shelves based on this association rule. So if you are going to purchase, likely to purchase A and B items together, you are likely to purchase C as well. So then they will keep that C product also very near to A and B. That's how they increase the sales of this market basket. Then you have lots of visualization tools available, and you can do the summarization, which is more of a descriptive analytics, uh, deviation detection. Like, do you get sometimes that you get an alert, or your spams is a concept which is based on this outlier detection or a deviation detection. So that is not from the set pattern, and it is a kind of a, so it is marked as spam. Or you would have seen that all of a sudden you get a mail that have you tried logging in from let's say Hong Kong from this IP at this particular time. If not, then change your password. So that is what is the outlier detection. So system understands that you have been logging from Delhi or Lucknow or some other area regularly, and all of a sudden if some login happens from some other country or some other geography, or so it's an outlier for them. So it automatically it identifies the outlier and then alerts you. Similarly, from the banks also have set up this outlier detection. So if your buying pattern is 5,000 or 10,000 rupees or in that range, and all of a sudden you buy a 50,000 or a 1 lakh of worth of a value, the banks will immediately call you, sir, is it you who is trying to do a transaction, right? So they get an alert based on the outlier techniques. Estimation, so it is predicting a class. So what is the sales till January or December 31st, and then based on that you can predict for your sales for March complete closure of next quarter, or even half a year or next year prediction. So based on your historical past, it is trying to predict your future. Link analysis for finding certain relationships between various variables. So these are categorized into supervised learning. Then you have unsupervised learning and a combination of semi-supervised kind of. And the fourth is classification into a reinforcement learning. So supervised is like if I have a truck full of fruits, and I know that I place a robot there and say that okay, fine, this is called an apple. Okay, so cluster all the apples in one basket, all the mangoes which is the orange color and in this particular shape, put it in a orange, and this is a banana shaped. So I'll guide the system to help it to cluster that or filter that various fruits accordingly. So that is what is supervised learning. So I'm guiding the system to make it happen, right? So be it classification or a regression techniques. Then you have the unsupervised learning, which means that I just place the robot there and I ask the robot to identify those fruits according to their characteristics and their properties, and then accordingly start clustering them. So which means like it identifies one particular fruit and creates a characteristics and places it in one of the bins. Then the next fruit, if it is the same characteristics, it will place it in the same uh, bin. It doesn't know whether it is a banana or an apple or a mango, right? So this is unsupervised. So it has clustered all the data. And when you say fine, so this is called the apples. So you have now made it a semi-supervised. So it has done the unsupervised part. So you would have seen in Google also that Google Photos, it alerts you and prompts you that uh, is that you in the image, or even Facebook does it, right? So it has done a semi-supervised kind of a learning, and it is asking from your historical past that this could be you and your friends, right? So it is, if you tag them, the next time it automatically starts tagging them as well. So that is a kind of semi-supervised learning. And reinforcement learning is primarily used in the robotic. So it is a reward and penalty concept. So if it action is taken, and if it is towards the target, you are rewarded, right? And if it is against the target, you are given a penalty. So it works on a reward and penalty. So it is reinforcement learning. When you are training, let's say a dog, right? So if it does a action based on your commands, you give a reward, right? You give a treat, and if it doesn't, you just give a small beating to it. So it had subsequently it has learned from those rewards and beatings or penalties that what it has to do. That is what is reinforcement learning. So these are various algorithms which are available from the industry. And in the supervised learning, in the classification, we have the support vector mechanism, discriminant analysis, Naive Bayesian, which is more of a predictive based. So it takes care of the probability also, and the nearest neighbor. Or in the regression, you have this linear regression, GLM, and different methods are there. And in the unsupervised clustering, we have this k-mean clustering, right? Dendrogram or hierarchical clustering, right? Neural networks, hidden Markovian kind of a models. So there are altogether these are streams in particular. So people can focus on any of these algorithms and then create a complete business model around it. So when we talk about this data mining task, they can primarily be clustered in these four streams. So be it clustering related or association rules based, then it can be a classification or maybe a predictive modeling, and the anomaly detection, which is the outlier detection. So in a clustering, you would see all similar kind of data placed together, nearest mean. So there are different algorithms which take care of it. And in the association rules, uh, it says that okay, if you buy, let's say, milk and Pampers for your kid, if you're asked to buy both of them, you are likely to purchase beer as well. Let's say. So that is a kind of an association rule. From the data, from a basket data, you have all the transactions with your transaction number and the kind of products you have purchased, and then you generate a complete association rule that these are the some of the rules which govern the complete sales of the market basket. So they give the association rules. Let if you purchase like A, then you are likely to purchase B as well. So let's say you have purchased a laptop from an e-commerce site. So they know that what other people have done. They buy, let's say, external hard disk or a USB drive in 3 months time. So within 3 months time, it will start alerting you that are you likely to purchase a pen drive? So we are giving you 10% discount. So that's how they understand that there is an association rule, and accordingly they are suggesting certain other products. Next could be your classification or a predictive modeling. So like when a credit card is approved or a fraud is detected, so these are all done using this classification techniques. So how a card or credit card is approved? So you may have good financial background and everything, then also it gets rejected, right? So these are based on the kind of data and the frauds that has happened, and those frauds which has happened, what is the symptom of that data. So it is trying to classify the users according to non-fraud and fraud case, or even those uh, recently your medical transcripts. So they scan all those X-rays of the patients, and based on the symptoms, they are able to identify whether it is a COVID patient or not. So based on certain type of cells in those X-rays, they are able to identify and classify them as a COVID patient or a non-COVID patient. So these are all kind of predictive modeling based and a classification techniques. So this could be an example wherein so based on that data, it has generated a classification model, and then you are able to predict a fraud, or you are able to provide the credit worthiness of a, and based on the predicting a credit worthiness of a customer, you are either giving approving a credit card or disapproving it. Then these could be other another classification task like I said, credit card transaction, whether it is legitimate or fraud, it can identify based on the previous patterns. Classifying the land cover by water bodies, urban. So in uh, Atlas, you would have seen a similar kind of a same height based, same temperature based different graphs, right? So they all are created using the classification techniques, or even predicting a tumor cell, whether it is benign or malignant. So these are all classification techniques which are used in the industry. One of the example could be a fraud detection. So predict a fraudulent cases in credit card transaction. So if they perceive a likelihood of a fraudulent transaction, they take a corrective action. So they get alerts based on the fraud detection techniques, and whether a particular kind of a particular transaction or a consumer is getting fraudulent, so immediately they stop those credit cards. It can also be used for the churn prediction of those telephone customers. So what they do, they try to identify a customer based on whether are you calling their help desk regularly, are you getting certain issues in your services, so are you trying to complain a lot now, or your bill payment has been delayed on a regular basis now. If those are the symptoms, the companies, these telephone companies, they understand that this consumer is likely to change the service provided now. So it's a uh, so they understand the churn based on the churn prediction algorithm, and then they try to retain you, and they will give you certain goodies. So 100 SMS free, you continue with us, we'll give you 100 SMS free or whatever. So they start giving you some loyalty programs, loyalty points. So that's how the churn prediction is based on the classification techniques. Clustering, we said, finding similar kind of groups, and which are unrelated or different from the other group. That's how it starts clustering that data. And then these are all used in the sales of, or doing the target marketing to these customers. So like it will cluster these data. The point is that intra cluster distances are minimized. So all these points which are within a cluster, that intra cluster distances are minimized, and the inter distance between two clusters, the distances are maximized. So these are the two criteria on which the clustering algorithm works. And then you can have the k-mean clustering or the hierarchical clustering, and this is a supervised clustering learning mechanism. So you group the data and to form a different categories, and that cluster houses to find distribution patterns, or maximizing the, so the principle is maximizing the intra class similarity and minimizing the within the class similarity. So based on two criteria, we have these two major algorithms. One is called k-mean clustering. So in k-mean clustering, what happens is, let's say we have a n observation data. So let's say hundreds of data, and we want to create three clusters or four clusters, let's say. So we randomly place three centroids in different points, and then try to capture the distance between that centroid and the nearest points, and try to find the minimum of them, right? So the aim is to partition these n observations into k clusters, in which each observation belongs to the cluster with the nearest mean. So then it becomes a kind of a iterative process. Then the points which it has taken, it tries to find out the mean of these points, and if the mean is away from this centroid which has been randomly placed, so in the next iteration it marks that mean as the centroid, and then calculates the distance formula again, and then it tries to minimize again. And if the mean of the points which has been identified is away from the centroid, then it in the next iteration it again assigns the mean as the centroid. So that's an iterative process, and finally when centroid and mean becomes same, that becomes one of the clusters, right? So it is assumed that within 8 to 9 iterations, the centroid and mean stops moving, and that is identified as the clusters. So this is called the k-mean clustering. Similarly, the concept of that Venn diagram, overlapping of the data and all that gives you the concept of a nested cluster, which is called the hierarchical clustering. And the presentation can be in a dendrogram. So if we want to create, let's say, two clusters in this, so we have to pass a line, horizontal line at the top just below the, let's say, point 3.35, which means that all these points, which is 3, 6, and 4, becomes one cluster, and 1, 2, and 5 becomes the second cluster, right? And let's assume we want to create three clusters. So which means that we have to pass the point at 0.25, and this becomes one cluster, right? Which is 3, 6, and 4. The point 1 is a separate cluster which has a separate, a different identity and different kind of characteristics, and the third cluster becomes 2 and 5. So as many number of clusters we want, we can uh, bisect this dendrogram accordingly, and we create our number of clusters. So this is another approach called hierarchical clustering, and this output is called the dendrogram. So where all it can be used? So market segmentation. So like I remember we were developing a e-commerce portal for travel industry, and we were doing a lot of data analytics on the data we had received. So one peculiar finding was that every Tuesday there was a surge in the sales. So it was a similar pattern. So we wanted to identify what was the symptoms of those surge or the sales going up on every Tuesday. So we tried to analyze it, and we came to know that, and it was more done by the ladies on that day. So ladies doing a transaction, and that too on Tuesday, and the volume was quite high. So we realized that the couple would have decided on Sunday to have a trip, and the lady would have asked to do a transaction. Monday, the guy would have forgotten, and finally on the Tuesdays, the lady would have done a transaction. And that was the case. We tried finding out with some of the case. We called some users, and that was the reason. So what we realized, we started giving certain discounts and goodies on Tuesday mornings. And so based on the data pattern, we were able to identify certain surge, and when we started giving certain discounts to the consumers, our volume increased by double within a month's time. Believe me. So that was the effective use of data science when we were developing the e-commerce portal for the travel industry. Similarly, next is a association rule discovery. So we have seen that in market basket concept, when we buy some different products, so we have a transaction ID and all the products which we would have purchased. And based on this millions of transactions and let's say thousands of products in a e-commerce portal or a market basket shops, then we can generate a rule discovery method. So like this rule comes out from this kind of a data that when you purchase milk, then you are likely to purchase Coke also, right? When you have milk, you purchase Coke. Majority of the cases, when you purchase milk, you also purchase Coke. And another rule could be when you purchase diaper and milk together, you are likely to purchase beer. So that these are the rules which govern you and help you in identifying the placing your shelves efficiently. So then you can place beer in next to your diaper and milk counters, right? So that helps you in increasing the sales because you see a pattern, and this pattern is your rule discovery from the data itself. So what is this association? So it is like uh, these are when you purchase diaper, you are likely to purchase beer. So there are two parameters which govern these rules. One is called the support, and another is the confidence. So support is it says how popular an item set is as measured by the proportion of the total transactions in which the item set appears. So it is the popularity of a particular item set. Next is your confidence interval. So this says how likely an item Y is purchased when item X is purchased. So that gives the confidence part of it. So support and confidence creates those rules in the association mining. And where all it is used, like market basket analysis or your medical informatics. Next comes the outlier detection concept. So these are the data which are away from these clusters, right? But is it always good? So maybe it's an outlier. So the data object that does not comply with the general behavior of the data and detects significant deviation from the normal behavior are called those outlier analysis, outlier points, and which can be either removed or taken apart and clubbed together to form a different cluster altogether. These are all outliers. So it can be named as spam in your email, right? Or it can be an alert from a different company country altogether. So when somebody tries logging in from a different company, that IP range has changed. So your behavior or a transaction which is all of a sudden 1 lakh worth of a transaction happens. You have been doing a transactions of 5,000, 10,000 only, but all of a sudden a 50,000 transaction happens. So it becomes an outlier. And if these banks have implemented these algorithms, so they come to know that this is an outlier and they get an alert. So immediately they based on that alert and the transaction ID, they would call the customer and try to find out whether it is you who has done this. Otherwise they will block and they will take a corrective action. So it helps them identify those frauds. So it could be a examples could be a credit card fraud detection or a telecom based fraud detection or a customer segmentation according to and medical analysis. So if you are able to identify COVID with the help to with the help of this outlier concept, you can cluster them and make them outlier also. Next concept is called the regression. So it is the measure of the average relationship. So it is more of predicting. So based on the historical past, you are trying to predict the future. So predict a value of the given continuous value variable based on values of the other variables, assuming a linear or a non-linear model of dependency. So be it independent. So what is independent variable in this? So the variables which is used to predict the another variable. And what is this dependent? So these are the variables which we want to predict. So let's say I have x-axis and y-axis and the data scattered around, and we create a regression line which is best fits into this model. So based on the x value, we are able to predict the y. So y becomes your dependent variable and x is your independent variable. So this formula would be y is equal to mx plus c. This we have been learning from our class 12. So m is the slope of that line and c is the intercept on the y-axis. So there could be some errors. So the actual formula becomes y is equal to mx plus c plus some delta or epsilon, which is the error based on the data which we get. So these are all coefficients. So c is a coefficient, coefficient of x is b, y is equal to mx, m is the coefficient of x here. So accordingly, we can calculate the value of y. Let's say I have the sales till December end, right? So I have a graph, and based on that same trend, I can predict the value of my sales in March next year or 2021. So these are used to do a future prediction. So I have this independent variable x and a dependent variable y and a lot of data scattered on this graph. So then I can plot a best fit model which will be a intercept, which is the c. So the formula becomes y is equal to b0, which is this intercept, plus b1x. So b1 is the slope of this line and some error, right? So error is your uh, the deviation from all these. So a simple regression would fit a straight line in this data. So these are some of the details how the observations and the predicted value differences, and we have to minimize this value. There are three approaches to this regression. One is called linear regression, another is a logistic regression, and the third one is a probabilistic Poisson distribution regression. Right. So in the logistic regression, it is more like a, even it is a, they are calling it as a regression, but it is more of a classification problem. So we are trying to best fit the model. It's a sigmoid model, and the values below this and above this can be treated as either 0 or 1. So any points above this are approved, or any points below this are, even though you have a best financials, then also you may get rejected. Your credit card may get rejected, right? With certain other parameters, maybe you may not have best financials, but then with respect to certain other parameters, your credit card can get approved, right? So approval, so it has two phases, two values, 0 and 1, true, false. You may have corona or not, right? So that way it is trying to classify a particular this problem. So this is actually not a regression method, it is a classification technique. So these are various approaches to the data mining, and quickly we all have read about it, whether it is mean, median, mode one. So we can represent them in various symmetrical data. So let it be a negatively skewed or a positively skewed kind of a graph. Accordingly, we know what kind of data is there in that, right? So these are various approaches to statistical output. We can plot it using the box plot, or a histogram, or a Q graph, which is a quantile plot, or compare between two different data sets, so quantile plot. So we sort the data, and then accordingly we uh, create the percentile of it, and then plot it in a graph, so we know where that is skewed or where that curve is increasing a lot. So we understand, we can analyze lot from the Q plots and compare two using the QQ plot. And then we have the scatter plot, which we can create the regression analysis. So this is about the box plot, where we can represent quartile 1, which is 25% of the percentile, 50% is and the Q2 and Q3 is your 75%. So anything, so this interquartile range is Q3 minus Q1, and the outlier becomes 1.5 times the IQR. So anything lower or above 1.5 times the IQR becomes your outliers. So any points which are far away or lesser values may become your outliers, and that this formula makes it you identify the outlier method. So this box plot can be presented with your 25 percentile or your median here. Then you can have the 75 percentile and certain outliers, which could be lower as well as the upper quartile, the outliers. So this is the method of finding the outliers from this data. So when you sort the data and present it in a graph and in a percentile, so that is called the Q plot, quantile plot. And comparing two different type of data, you can use QQ plot. So word cloud is again a method of plotting the data. So against your Twitter different key hashtags, you can identify what other topics people are talking about. So be it business analytics, and then when you are talking about, you have search for business analytics, then lot of other keywords would be there, like modeling, predicting, right? Regression, statistical modeling, planning tools, OLAP. So these are other different technologies and hashtags that people are talking about, and the size talks about the frequency of it, right? And this frequency and plot can also be used for the sentiment analysis. So what keywords people are talking about negative about this product? So people, these companies which these are product companies, they've started using the sentiment analysis from the different social media mining. So what they do, they extract a lot of data over time, and then they find out what is the sentiment of the people, whether they are talking positive about the product, negative about the product, or still they are neutral about it. So based on that, who is the most critic of these products? So they will try to connect with them and try to find out the issues from them, right? These are various other visualization just methods. You can go through them. I'll share this presentation with you. And when we say building and maintaining a complete data mining system, so these are 4-5 step process. First, you have to identify the problem statement, what you are trying to achieve from this data science project. So that you have to very clearly identify. Accordingly, then you have to collect the data, right? And collect the data from different sources. If you have to do a whether what people are talking about my product, let's say that's a problem statement. Are they positive or negative about me, right? So then you have to start collecting the data from Facebook or internet or Twitter or some other whatever sources you have, right? And then you have to then transform the data into some meaningful information. So you have to run your models on that and identify whether people are positive or negative about it. If that model fits into that data, you can move it to production. If there are certain changes required, you can do a fine tune of this model. And this can be presented in the complete business intelligence architecture, which is different data sources. Could be your external data source or your operational databases. You can extract using ETL tools or some complex event processing engine. And then you can put it, you can move the data into a relational database or your big data, which is your MapReduce engine. And finally, you can use OLAP servers or data mining and text analytics engines for the reporting purpose, which can be presented into those different dashboards and different outputs, which are meaningful data. So from data to insight is what the startup should use. So I said problem statement to preparation of the data to use of algorithm is the pre-processing part, right? And majority time goes into the pre-processing part. When you have the data ready, you can then run your models, right? And fine tune it. And when you are comfortable, it's an iterative process. So you deploy it, manage this model, and take the feedback. Based on the feedback, you can then again refine and tune your model again, and then deploy it. So that's how the life cycle of a machine learning process is. So this is what we have discussed, that supervised, unsupervised, and reinforcement learning, and different algorithms for related to that. So these are top 10 algorithms which industry uses. So this is last year's data, and most of them use data science for regression and clustering, and then this decision rules, decision tree, and association rules. So these are the three, and for visualization. Next is a k nearest neighbor, k mean clustering, principal component analysis, statistics. So these are other methods that are used, but these are top ones are regression, clustering, decision tree, and rule mining, or the visualization part of it. So people ask, what are the skills required for being a data scientist? I would say that these are the three categories of skills. One is you need to understand the statistics part, right? So which is like your statistics, your probability, your hypothesis testing, your multivariate analysis, right? So that becomes your actually becomes your data science skills, which model to use, right? And then you need to be a computer aware guy also. So be it your computer science, data structures, algorithm, parallel processing, right? Different languages, cloud computing, hyper converged computing, and all that, right? So these are IT skills that are required. And then you need to understand the business as well. What is the output you are getting? How it will affect the business? So that will come when you are part of the business team. So correlation, modeling exercises, business understanding, right, and ability to assess which models are feasible. So IT, the data science and the business skills makes up the complete data scientist. But it is a data mining is a multidisciplinary activity. It involves statistics, visualization, high performance computing for big data and all, right? Database technologies, various algorithms, applications, machine learning, pattern recognition, and all that. So different data science models. And operational research is also required for prescriptive analytics. Prescriptive is a future, predicting future with respect to different variables. So statistics, which is more suitable for the descriptive analytics. So I'll talk about descriptive, and then you have the predictive and cognitive analytics, which is your machine learning. You are predicting something, and then operations research is optimizing this output. You are not controlling which variables will change the output, right? And these are different other domains that are required for being a data scientist. So whether your domain knowledge, so be it business development, project management, budgeting, governance, compliance, optimization, they are part of the domain knowledge. And from the mathematical or data science perspective, various graphical outputs, various algorithms, uh, Bayesian statistics, machine learning, data mining, right? And from the technology perspective, you need to understand data management, big data, right? System administration, database management, cloud computing, and all that. And with respect to what efficiency is required is displayed in this graph. So some popular data science tools are like Python, R, SQL Server. So you need to understand SQL because you have to multiple times connect to the database. Java, Amazon Machine Learning, right? Hadoop, Tableau, Apache, Spark. So these are various other technologies that are prevalent and common with the data scientists. So this is what I was talking about. So if you have this information, so as you move with the difficulty of programming, the more value you get in the data science or the insight. So if you are using what happened, so it is more of a historical past. So it is called the descriptive analytics. It is your statistical models run on the data, right? So data, so you get the descriptive analytics. So why did it happen? So it is more of a diagnostic analytic. So you are identifying what parameters made it happen, right? So it is a business intelligence. So this is so the data with some business intelligence, it makes it a diagnostic analytics. What will happen is a predictive. So data with forecasting model makes it a predictive analytics. So data, you are using the data and trying to forecast something is a predictive analytics. And the highest part of it is called prescriptive analytics, that how can we make it happen. So it's a combination of data, the business intelligence, and the machine learning. So if the data, what variables may change to get a desired output, right? So that is forecasting a value and manipulating the data variables, so that based on those variables you are uh, targeting a particular forecast. So that is the highest level, which is called the so it's more related to the operational research part of it, prescriptive analytics. So summary is that all these data is being captured and we are drowning in data but starving for knowledge. So that is the ultimate point, that a lot of data is being collected and we are actually drowning in data and starving for knowledge. So somewhere we have to start using data science to get best out of this data mining for our knowledge. Quickly, I would say that why now? So because of the cost of the storage has decreased, compute power. So even your mobile has a great compute power, bandwidth. 100 MB of bandwidth is available from your home also, right? So because of, and a lot of investment has gone into the AI part. So this R, people, even a small developer can learn R and use all those mathematical models which are now readily available with R packages. So be it R, Python, this Python and all. So these are all what lot of research has gone into creating those algorithms. So which has made data science as a popular as of now. What next? So it helps in reducing costs, helps in detection and prevention of fraud, right? Helps in extrapolating the current trends. Even Government of India has released a national strategy on artificial intelligence. So read this article, which is available from niti.gov.in, and this white paper talks about which areas Government of India is focusing on. So major focus of business analytics would be used in healthcare, agriculture, education, smart cities and infrastructure, and transportation. These are the areas where Government of India is focusing on. And lot of data is, so if you want to develop your own models, you can use a lot of data from these sites. Government of India also has this data.gov.in. Other countries also have a lot of open data available. So these are some of the case studies which I wanted to share. One was from the uh, Indian Railway Reservation System. So this is what the history of Indian Railway Reservation System is. So we had developed it in 1995, and all this was this concert was implemented by 2000, and then we had developed the web part of it, e-ticketing, and finally these are all various clusters of PRS. PRS is Passenger Reservation System central servers. Delhi, Bombay, Chennai, Calcutta, and Hyderabad has now become the DR site. So we have been developing a lot of data now. So all this data has been collected into a data warehouse now, and now a lot of business analytical tools have run on that data warehouse, which gives you this kind of an output. So even in your IRCTC portal now, you would see that what is the likelihood of a ticket getting confirmed. You will start getting this method now, right? If there is a particular waitlist ticket, waitlist 48, then what is the percentage of that ticket getting confirmed, right? Waitlist 30, the wait confirmation is 64%. So it takes care of the time series. So it is analyzing whether there was a Sunday on that day, or an additional coach was added, because of that the waitlist had. So that those are the outliers, right? So based on those outliers, it will create a complete probability model, and then give you this probability model. Have you seen this, guys? Right? So this is all because of a lot of 30 years of data has been collected and created into a data warehouse, and now running those BI tools, this time series analysis, the ARIMA model, different methods are available which are used to predict the chances of a probabilistic model to having the ticket confirmed on a particular waitlist. So these could be other use cases. The user churn prediction, right? We have discussed recommendation engine, upselling and cross selling, customer segmentation for the sales team, market campaign optimization. So you need not send, so budget will exhaust if you start sending or marketing your collaterals to each and every one. So you have to do a target marketing, product inventory optimization. So how to effectively, so whatever products are being sold, right, effectively you manage the product optimization. Dynamic deal scoring, I talked about the e-commerce site. So on Tuesdays we started giving dynamic deals based on the sales pattern and the outliers, and our sales increased because of this. Even in agriculture, a lot of use cases are available. Crop and soil monitoring can be done using those sensors, IoT based devices. Predicting the agricultural, and I'm also one of the member of this uh, steering committee on Ministry of Agriculture. So I'll talk about one of the use case in the next slide. Supply chain efficiencies, right? Image recognition for soil science. Based on that, it can identify the pest and other diseases. So like kisans have been given, or these farmers have been given with certain scientific applications. So based on the image that they scan, they can identify what kind of a this pesticide they have to use. So there's all using data science now. Minimum support price estimation. So MSP, we already know that a lot of agitations are on. That's because you have to implement MSP. That is what they are. So MSP, we are going to this is the model which we are working on. So we are trying to create a machine learning model for estimating the minimum support price using the forecasting model. So it's a multivariate agricultural commodity MSP price forecasting model, and we are taking a lot of inputs from eNAM, which is e-National Agriculture Market, soil health card given to farmers, M-Kisan portal, right? And these are other this price optimization allows the retailer to consider the factors such as the competition, the yield prediction using ML, right? Weather forecast. So based on different weathers, the yield would be different. Seasons, the special events, holidays. Accordingly, the MSP should change. If there is a it's all because of demand and supply ratio, right? So based on that, the MSP should vary. Macroeconomics, farm machinery, the cost of tractors and others, input costs like seed, fertilizer, pesticide, whether you have warehouse in this area, cold storage in that area or not. Accordingly, the MSP should. So as of now, government is only able to do this predictive modeling and come out with MSP once in a while, right? Let's say once in every year. But and for the same, for the complete country it is the same, right? But in different regions, because of different uh, parameters, it should vary based on the demand and supply. So that's how government is trying to come up with a model, dynamic model of MSP, which can be worked out area wise, district wise, state wise, right? Different geographies. And these are different algorithms that we are going to use, using the dimension reduction, naive Bayesian algorithm, and the ARIMA model for forecasting the MSP prices. Even I have read about the AKtU interacting with the KGMU to develop this artificial intelligence powered computer model that can predict COVID using the chest X-ray. So it has taken lots of chest X-rays. Accordingly, it has classified them with COVID patient or non-COVID patient. So using the various regression, Poisson regression or different regression method, it has trying to classify whether a particular kind of an X-ray is a X-ray of a COVID patient or not, 0 or 1. Very interesting. Last 2 years back on FIFA 2018, uh, it had used this deep neural network using the IoTs on the players. So what they have done, they have given a IoT sensor based devices, and then they would calculate what is the sweating. So the managers had their dashboard on their hand, and they would identify which particular player has sweated a lot, what is the pulse rate of each player, and how much they have run. Based on all that, they identify what is the fatigueness of these players. So accordingly, they would efficiently replace those players. So they have been using this based on the IoT and the machine learning and neural network. They are identifying the efficiency of those players, and more IoT and sensor based data would be used in coming FIFA and other games as well. So I'll just quickly close by saying that AI enabled real time surveillance in the smart cities. It will have 1 billion cameras by end of this year, and each camera generates around 30 information. So 30 billion information per second kind of volume is being captured. So is it possible to do this using manual eye and all? Can somebody look at these many transactions? No. So it has to be all these automated tools, data science tools, which will identify the outliers. So it could be a complete surveillance system, real-time surveillance system, which can identify, let's say, vehicles or license recognition. So text mining, image recognition, right? Face detection, right? All this can be done using the data science. Or even like in COVID scenario, whether a mask has been worn or not, it can detect the social distance, or whether somebody is wearing a mask or not. All this can be done using the AI analytical tools. It can also identify to the extent that seat belt is fastened, whether the person is on phone, right, riding without a helmet. All these can be identified using the AI and machine learning algorithm. Like I have last year, I have done a sentiment analysis on Havel's Adonia when they had launched, right? So 3 months after that, I had done the sentiment analysis. I have extracted the Twitter feed, and I was able to get some positive and some negative out it, and the extract was shared with Havel's team, and accordingly they did a corrective action on that. So even text mining can be used with any of these keywords, and I have done this for FIFA 2018, IoT, and data science, and accordingly, whatever keywords are associated with them, I could collect them. So these are some of the recent articles of mine that has been published, and these are related to the fintech startup or your data science case studies or blockchain enabled. So uh, good to read them. Many of the students ask me what are the good books on data science and machine learning. So these are few which I recommend, and I've read about them. So Ken Black's statistical modeling, data mining from this finger, right? And discovering statistics using R, ND field, data science for business. So these are some good books that you should focus on. And I would finally say that data science is everywhere, be it internet, image classification, speech recognition, language translation, whatever, right? In medicine, drug discovery, COVID-19 detection, everybody is using it now. Media entertainment, right? Media captioning, automatically it identifies the voice and converts it into. So these are all voice recognitions, and it's all real-time translations. Security, face detection, video surveillance systems, satellite imagery, autonomous vehicles anyway is picking up. So I would finally summarize that data science is not a process. It has to, it's a process, it's not a product. It takes time. Believe me, it's an evolution, not a revolution. So testing it is a key. Evolving the standard test cases is critical. So three T's are try, test, and tier it. So repeat it, improve it, and grow it is the mantra of success mantra for data analytics. So my meaning of data and science is torture the data and it will confess to anything. That's the intent of the data science. But for new startups, I have certain tips which I wanted to share. So few of you would start the new company. So startup should have new product or service to be offered, or a new idea which addresses an existing challenge, and it should have a scalable over time. Team capability should have these five key personalities of the to be a successful model. So the technocrat, uh, superstar kind of person, an operations leader. You need to manage the complete show. So there are an operational leader is required, an industry veteran, very needed. Why so? Because he or she understands the nuisances of the industry. So industry veteran is key to the success. One sales and marketing guy and a finance guy. So these are 4 5 people which are key to a startup. Register your IPs, so intellectual properties or patents of your idea and solution at the right time. Not do not hurry about it. So appropriate time when you are comfortable that this will scale up, then only go for your IPs. Startup lose their money too fast as the world changes the business models very frequently, right? So accordingly you have to change. So you have to avoid this fast uh, burnout of your money. Startups have to reinvent themselves constantly with changing business times, with effective use of data and analytics for the business decisions. That's key to success of the startups. And this data driven insight helps the startup take a quick leap over their competition. So these are some of the tips, but some of the startups fail. That I have analyzed some of the key reasons for that. So what are these mistakes that have killed the startups? A single founder. So associate with a good friend or some those two have you two should have a different skill set. You should complement each other. Selecting wrong platform. So they start with some open source, and finally they struggle in modifying those open sources, and finally uh, the business would have moved further, and they are still struggling with the wrong platform. Slowness in launching a product or launching it too early, right? Having a specific user group as target, so you have to expand your horizon. Think of the mass in so don't target a particular kind of a customer. Your product or solution should be scalable. Raising too little or raising too much of a money, that is also a killer. Half-hearted effort, not wanting to get your hands dirty, you have to get into that business. Fight between the founders, that is also one of the issues. Startups have no sales experience, that happens with most of the startups, and hence revenue generation is a challenge. So when you don't generate revenue, you end up finally closing your startup. So focus on whatever sales, small, big, whatever, start the revenue part of it. Have a good sales guy, and no effective use of social media, data driven insights, or disruptive technologies in your business. So if you don't use them, you will end up closing your startup, right? So finally, I would say that starting a startup is not about sticking to your vision approach. Startups are more like science, so where you need to follow the trail wherever it leads. So change your business models accordingly. Point is, so keep innovating with the effective use of data driven insights. That was what I wanted to share with you all, and my suggestion to the startup set, that keep innovating, and with the effective use of the data driven insights.
Thank you so much, sir. And now I have 3 to 4 questions from our audience.
Yes, please.
First one is Mr. Ashutosh Kumar is asking how the AI would judge a candidate or a person abilities on the basis of single sheet and the behavior on internet.
So it is not just one behavior, it has understood from various different parameters previously. So based on the historical past, you get certain parameters, and based on that only AI works on the data, right? So data comes from your historical past, and when you collect that data, you get the symptoms of it, and then you are able to use the AI for your other parameters. So it is just not you, it is based on certain other data that it has collected, and then it predicts the outcome.
Right, sir.
Yeah.
One another friend is asking, in the age of internet where the data is the new crude oil, and into hike and by the every tech and non-tech industry, how a new startup will justify the willing questions to eternity with the big data-driven industry?
Can you
So this question is wrote in the QA box.
Let me open the QA box. No, I'm not. So can you repeat that question again?
Yes, sure. In the age of internet, where data is the new crude oil, and into hack and by every tech and non-tech industry, how a new startup will justify the willing questions of eternity with the big data-driven industry. I think there is something.
So we'll take that question later in case if he's able to explain that.
Right. Mr. Bittu Raj is asking, what is the difference between machine learning and data analysis? And the second question is, what the reason of machine learning for being a subset of AI?
Okay. So we need to understand what is the data analytics, the machine learning, and the artificial intelligence AI part of it. So when you do more of a statistical analysis, right, and predict certain based on the data, so it is. I've talked about the Gartner's cycle where I was talking about the data-driven insight, which is the predictive analytics, right? So it was a more of a descriptive analytics. So that is the data science. When you use certain algorithms which are based on prediction or regression, so that is the machine learning part. And when you optimize it based on certain algorithm, based on operations research, or deciding on based on certain algorithm, which is the artificial intelligence.
Right. I think this is also captured in your first 4 to 5 slides.
Yes.
And I would like to inform our students that this lecture is already available on YouTube at University Digital Education channel. So anyone if missed lecture or part of lecture, he can visit our university channel. And I have already shared the link in the chat box of our YouTube channel so that you may access this lecture again and again, because this is a very interesting and very knowledgeful session. And the participants of computer science branch will definitely can learn a lot from this session. So at the end of this session, I would like to thank you, sir, on the behalf of our university, on the behalf of Honorable Vice Chancellor, sir. So Vice Chancellor, sir, you have spared your valuable time for our students and given a glimpse of such type of excellent industry expertise. So I would like to thank you once again, sir.
Thank you so much. Thank you, Abhishek, and thank you, Vineet Kansalji, and all the students and faculty from AKtU. I would like to thank you all. And in
Our
case
few students are also asking, sir, may I get the PPT? So PPT की जरूरत नहीं है, वो ऑलरेडी लेक्चर यूट्यूब पे है. आप इसको बार बार हाँ यूट्यूब पे देखेंगे तो पूरा आ जाएगा.
Sure.
Thank you, sir.
Thank you so much, and have a nice day, everyone. Thank you, everyone. Bye.
Thank you, sir.